welcome back. In the last video, we looked at model selection methods to determine our best model. We also need to check our assumptions on our model. And one assumption that we need to check is whether or not we have constant variance. So how do we check this? Well, we're going to use the Breuch-Pagan test. And our Breuch-Pagan test regresses our squared residuals against our x's to find least squares estimates to use in the test. So, what do we have? Well, our test here is that each of our variances are going to be the same. That's our null hypothesis. Our alternative hypothesis is that at least one of these pairs of variances is different. This would suggest that we have non-constant variance. Now, with our Breuch-Pagan test, we're going to use the continuous data in our variable, but we are not going to use sex in this example. So how do we do this? Well, our first step, we need to obtain our residuals and our sum squared residuals from our original model. Notice, without sex, our linear model is going to be weight regressed against head length, head width, neck size, body length, and chest width. And so we'll run this model, and what we want to get are the squared residuals that I've called BP val. In our second step, we want to regress these squared residuals against our original regressor variables. And so I've called this BP val LM. And I'm regressing my BP val, my squared residuals, against my original regressor variables. I'm going to obtain what I'm going to call sum squared regression star for the model in step 2. So, what I need to do, first I want to get a summary, and then I want to take a look at my analysis of variance function. I need sum squared regression star. Now, that is the sum of these values. Step 3 is compute the Breuch-Pagan statistic. So I'm going to use sum squared regression from step 2 and sum squared residuals from step 1. And I'm going to get sum squared regression star over 2 divided by sum squared residuals over n quantity squared. This is my Breuch-Pagan value. So I've called sum squared regression star over 2 my numerator, num, or num1, and sum squared residuals over n quantity squared, denominator 1. And so notice, 51537 plus 493666 plus 48727 plus 1241787 plus 31799 divided by 2. That's num1. In denominator 1, this is my sum squared residuals from my original model. And from my original model, if we look at sum squared residual, we'll see we get 95797. Now, again, divided by n, well, there are 138 observations in this data set, and notice that this is squared. And so to calculate my Breuch-Pagan value, I simply need to take num1 over denominator 1, and I get 1.93771. Breuch-Pagan is a chi-squared test. So we're going to reject the null if our Breuch-Pagan is greater than our chi-squared at alpha with k minus 1 degrees of freedom. Now notice, there are 1, 2, 3, 4, 5 values in this model, plus the intercept. So k minus 1 is going to give us 5. And so if I look at the probability of a chi-squared with 1.93771, I get 0.8576952. Clearly, at any alpha chosen, this is greater than that alpha, and so I would fail to reject this and say that I have constant variance. But there's an easier way to do this. Now, this would imply that I need to load the LM test package, and then I could use BP test, with YLM, and notice I've included this studentized equals false. When I run this, I get a Breuch-Pagan value of 1.9377, 5 degrees of freedom, a p-value of 0.8577, which is essentially what we got when we calculated this by hand. Thus, we would fail to reject our null hypothesis. By failing to reject our null hypothesis, what we're saying is that we don't have enough information to be able to conclude that there is non-constant variance. That's what we want. We want our variances to be constant. Okay, that's it for this video. In the next sets of videos, we're going to begin looking at analysis of variance. See you then.